So for number 65, we've got a small block of mass 0.5 kilograms released from rest at the top of a curved wedge of mass 3 kilograms, which sits on a frictionless horizontal surface. When the block leaves the wedge, its velocity is measured to be 4 meters per second to the right. A, what's the velocity of the wedge afterwards? Well, I drew a before and after picture here just so you can sort of visualize it. The total momentum beforehand is 0 because everything's at rest. Because of that, we immediately know afterwards the total momentum still must be 0. But if you check, the momentum of the block is going to be its mass times its velocity 4, or 2, going this way. And again, forgive me, I've left off units here, but again, it should be kilogram meters per second going that way. Since the total momentum is 0, we can immediately calculate the momentum of this one, which has to be 2 in the opposite direction. So the wedge itself is moving backwards. How do we figure out its velocity? Well, we know its momentum is mass times velocity. Its momentum is 2. Its mass is 3. And I'm going to leave it as a fraction. The velocity it's going to move backwards then is 2/3 of a meter per second. Yes, you could write as a decimal. But this is the answer to A, 0.67 meters per second. Part B, what's the height of the wedge? And you're like, wait a second, how am I supposed to solve this one? Well, in this case, it's the gravitational potential energy that's giving this whole system the kinetic energy we see at the end. I'm going to assume that everything in here is frictionless, including the edge of the wedge. We know the surface is frictionless. I'm going to assume this is frictionless as well. Otherwise, we'd have E dis, and that would mess up this result. So how do you solve this one? Going back a couple of chapters, initial energy plus work equals final energy. In this case, we start out with gravitational, and it ends up all as kinetic. There's no energy lost due to friction. Initial gravitational potential energy, it's a 0.5 kilogram block. I'm going to make gravity 10. Height is h. We don't know. That's what we're trying to solve. And at the end here, it's going to be equal to the kinetic energy of the wedge plus the kinetic energy of the moving mass. Solving that, you can very quickly discover that the height of the wedge should be about 0.93 meters. It's just a bit of number crunching here to get to that answer. Hopefully that helps, and that's the answer to B. See you soon.